So our next video is going to look at resultant moments. Now, if you haven't looked at the previous video on moments, I would advise that at this point we just go back and have a look at that just to make sure we're clear on what we're talking about when we are referring to moments. So, looking at resultant moments then. When we have more than one force acting on a rigid body, we can calculate what's called the resultant moment by considering the forces in the clockwise and anti-clockwise directions separately. So if we look at this example here, we're being asked to calculate the resultant moment acting about the point P, and we're being asked to assume that the rod is light. Now, that assumption of the rod being light is important because in reality, this rod would have some weight, some mass to it, so there would be a force caused by the weight of the rod. In this instance, we're not considering that. In some later examples, that's something that we will look at. So the first thing we are going to do is, if I take moments about the point P, so that's the point that our rod is being pivoted around. So if we take moments about P, moments about P, and then if I consider each of those moments in turn. So if I just call these points, I'll just label these just so that we've got some reference points. So I'll call that A, this one B, and that's C there. So the moment of A, well, moments from what we looked at before, that was the force times the distance, as long as the force was acting perpendicular, which these all are. So the force is 8 and the distance is 1. So that would be 8 times 1, which gives us 8 Newton meters. And if this was the only force acting, that would cause our rod to turn anti-clockwise. So we've got anti-clockwise. Our next one, so the moment of B, well, the force is 7 and the distance is 2. So 7 times 2 would give us 14 Newton meters. And again, if this was the only force acting around that point pivot P, our rod would turn in the anti-clockwise direction. Finally, we've got the moment of C. Now the force at C is 6 newtons. The distance from P, well, I've got this 2 plus that 1, so that distance from P is 3. So I've got 6 times 3, that's 18 Newton meters. And if this was the only force acting, then our rod would turn in a clockwise direction. So we've been able to work out the 3 moments that we've got, and we just want to find the resultant moment. So if I find the sum of the anti-clockwise moments, anti-clockwise, I've got 8 plus 14, which is 22 Newton meters. In the clockwise direction, we've just got this one here, so that was 18 Newton meters. So the resultant moment is going to be the difference between these two. So if I do 22 subtract 18, that is going to give me 4 Newton meters. And because anti-clockwise was greater than clockwise, the resultant moment would be in the anti-clockwise direction. So 4 Newton meters anti-clockwise, and that there is our answer. That's the end of this video. Thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.